Thank you, everybody. If there's anybody else out there who is going to come in. So I want to start the first of our panel sessions. And this is with Andrew Pape-Salmon and Christy Love. Andrew is a fellow of the Academy, and I think he'll probably explain a little bit about his journey that got him here. When I joined the Academy as Executive Director in 2019, there really was only one major program running, and that was the one that was being pursued by Andrew, along with Andreas Athianitis at Concordia. And it was a very interesting model to me because it showed how individual fellows could actually leverage the Academy as a platform to effectively promote important social and in fact, economic programs. And since then, there's a number of others who've started up, and we've been trying to follow the same model. And, you know, reflecting on a few of the comments that the Senator and the Minister made, and the Dean, for that matter, earlier today, this interface of policy and technology is really a place where the Academy can add value in the national dialogue. And I think you'll see from this discussion that one of the things that Andrew's brought to the table is the ability to translate between governmentese and engineeringese, so I'd like you, first of all, to listen to the content, but also perhaps to reflect on how areas that you yourselves are working in might follow a similar model that we would get behind at the Academy. So with that, Andrew, thank you so much.
Welcome to Victoria, my hometown. And I also would like to acknowledge with respect the Lekwungen-speaking Indigenous peoples on whose traditional territory we are gathering today. I guess there we go. So Robert is correct. We developed a program to advance essentially engineering practice and public policy in the domain of buildings. You know, and buildings is something that is very prevalent in all of our lives. Every Canadian uses buildings, lives in buildings. Much of our commerce and our economic output is linked to buildings. And I was at the time working in the building sector with RDH Building Science with Christy Love, and very interested in public policy. In fact, when I finished engineering school in '94 in Waterloo, I was at that time interested in renewable energy and hydrogen, and realized there was only 5 jobs in solar energy all across Canada, one of which I had taken previously at Queen's University doing solar thermal research, and I thought, I want to work in this field. We have to change public policy. So I pursued a master's in public policy immediately following my engineering, and have now been working in public policy for 25 years. Next week, actually later this week, I'll be joining the Ministry of Emergency Management and Climate Readiness to work for the Honorable Bowen Ma. So it was great to hear her this morning. But basically, I agree with the previous session and the discussion about the importance of engineers interfacing with policymakers. And of course, there's 2 or 3 different types of policymakers. There's the elected officials, and there's the professional bureaucrats, and there's also the institutions. And we often forget about the institutions and the inertia that they have and the power that they have. And these are government organizations such as BC Hydro or the BC Utilities Commission or BC Ferries or the Technical Safety BC. These are the ones that I intersect with, that are enabled through government legislation and are often delegated to and empowered to lead on public policy issues and working within the confines of their legislation and their fiscal regime. Basically, engineers have a perspective that can be shared, and for several years I was part of a group called Bridging Government and Engineers that Engineers Canada had, and that was disbanded, unfortunately. And they did have once a year engineering on the Hill, that being Parliament Hill. So what I'm here today to talk to you about is the possibility that the Canadian Academy of Engineering could fill that gap that was created when Engineers Canada disbanded the Bridging Engineers and Government Committee. And the format that we're proposing is through a roadmap to resilient, ultra-low energy buildings with deep integration of renewables, which as of an hour ago has been posted on the Canadian Academy of Engineers webpage. And we're seeking, for the next 2 months, the word draft is on every page of the 80 pages, and we're seeking comment from inductees to the fellowship of the Canadian Academy of Engineers. And if somebody happens across that PDF document who's not an inductee into the fellowship, they're welcome to comment too. But what is the roadmap? It's guidance. You know, this is not about lobbying, and I do agree with the Senator Galvez that there are many lobbyists. And I guess technically if CAE goes to the Hill to talk to elected officials, we will need to register as lobbyists, or if it's in Victoria. But in fact, fundamentally it's about guidance and this idea that we have some opinions to share. And it won't necessarily be highly referenced in the literature. This is one thing I've found in the building sector and the public policy sector is the literature is incomplete. And much of the literature is actually government documents, like the Clean BC Roadmap to 2030. And so formulating opinion based on experience and based on research and the literature is something that we can offer. The roadmap provides a compelling and achievable vision for the building sector and goals and metrics, measurable indicators that we're achieving those goals. Case studies of buildings in Canada, not in Europe, in Canada, that have achieved the vision of 2050 today. And my contribution was to prepare 5 policy principles. So not policy recommendations even, but principles. So not, you know, we need to regulate X, Y, Z through this institution with these guidelines. Rather, principles so that when policymakers are preparing public policy, they consider these aspects. Because what's interesting, I always like to talk about the diversity of politics in Canada. Over here, province of Saskatchewan, in all due respect. Over here, the city of Vancouver, in all due respect. They're like night and day. They're completely different in terms of how they get things done. City of Vancouver, incidentally, is a charter city. It's like a city-state. It has its own charter. It has its own building code. And it is, I describe it as pursuing the bullet train to decarbonization. It is going very fast. And by going very fast with a very heavy-handed regulation, there are unintended consequences. There are significant losers, and there are also winners. And a more thoughtful and longer time frame, which I call the bike path to decarbonization, is maybe something that other jurisdictions will pursue to find the best fit for their jurisdiction, for the opportunities and the experience of their sector. And this roadmap aims to be completely apolitical, non-political, such that the province of Saskatchewan and the city of Vancouver see value in the principles. In other words, the principles are non-political. And finally, a call to action for the engineering profession and a roadmap for engineers to catalyze. transformation. These are the 4 co-authors and the sponsors. The initial sponsor was actually the Pacific Northwest Economic Region, which is 5 Canadian jurisdictions and 5 U.S. states working together on common interests around the economy, society, the environment, disaster resilience, things like crossing the border so that making it easier for north-south trade to occur. And I think we've been very successful. And the Canadian Academy of Engineering, which essentially started to sponsor this project around 2017. So in 2014, the roadmap was born at the Penmore Summit in Whistler. And in 2019, we hosted our first workshop at the Canadian Academy of Engineering. And just today, on the very last bullet, we have posted this roadmap for your comment. The vision is that climate change mitigation and energy affordability necessitates a transformation of Canadian buildings. And the design of buildings, transportation systems, i.e., when they're used or charged at buildings like electric vehicles, and industry must change with an additional emphasis on increasing energy efficiency, exclusive use of zero and net zero carbon fuels, including hydrogen. And incidentally, hydrogen, the big thing in British Columbia these days is turquoise hydrogen, which is not green and it's not blue, and I'm sure we'll be talking more about that. But it's actually derived from fossil fuels. It's derived from our abundant resources of natural gas in this province, one of the largest in the world, and it's decarbonized. And by the way, we have a hydrogen gas station in Prince George that just opened, fueling long-distance trucking via what's called a hydrogen as a service kind of business construct, where the truck engines are owned by a third party and people are essentially leasing the use of that hydrogen engine. And bolstering resilience. So let's compare 3 countries. The bottom one is Sweden. It uses about half of the energy per capita for buildings. And Canada, you can see the blue line is still about 50% fossil fuels. In Sweden, there's a balanced approach to both biofuels and electricity. In Norway, not surprisingly, they've pursued the electrify everything approach. So what's interesting about the electrify everything approach is the question of resilience. And I do want to point out, we're on Vancouver Island. We have, historically, we had a high voltage DC transmission line serving Vancouver Island. We consume far more electricity than we generate on Vancouver Island. And during the heat dome in June of 2021, one of the underwater power lines actually went out of service, the one north of here, the Chikai-Dunsmuir, that crosses around Cowichan Bay. And the heat dome actually caused damage to that underwater transmission line, the fluid that protects it physically and from the pressure of being underwater, I guess, had some damage. And I actually just Googled it this morning, and BC Hydro did announce that there was that damage in 2021, shortly after the heat dome, and suspects that it was related to it, and I haven't found further information. But forest fires, wildfires, and large storms are other threats. So the roadmap doesn't cover the entirety of the resilience topic. It only covers the resilience of the energy system, because of course, in a heat dome, you want your power to be working so that you can run the air conditioner. So energy resilience is really, in my point of view, professional point of view, one of the top 5 aspects of life safety in a natural disaster, is that you've got power. And so that's the focus of the roadmap. So the focus that I had in authoring the roadmap, and the words within the roadmap that I wrote relate to my 25 years of experience, and also some recent policy related documents that have been made available by governments and institutions. And it starts by talking about, what are the various government policy measures to decarbonize buildings. And the purple ones are what we call demand-side measures that really try to influence the decision-making that occurs in buildings and how that relates to decarbonization. And the green ones are supply-side measures that are controlled by public utilities and essentially public utilities. Some of them are natural monopolies, like BC Hydro and Fortis BC, and others are in competitive marketplaces. And so just to explain the two axes, the y-axis talks about the proportion of the total building stock that is touched by the policy measure. The x-axis is the proportion of emissions for an individual building that is influenced by that policy measure. So the top right quadrant is what we're really aiming for in the long term, because that will allow us to decarbonize the entire building stock. And we're not just talking new construction. We've been putting most of our social agendas on the construction of new buildings for the last 30, 40 years. In fact, the National Building Code of Canada, which was established in 1941, BC Building Code in the 70s, exclusively focuses on new construction. What we're talking about a lot here is existing buildings. How do we influence the remaining 97% of the building stock in any particular year? Because only 3% of the building stock is new construction in a particular year. And we're trying for the largest impact, which is the top right. But those are the big hammers. Those are the big policy hammers, like decarbonizing the natural gas pipeline system, which BC is alone in making a policy commitment to regulate. So it says there are methane, energy, supply, emission caps. So BC has committed to decarbonizing the methane grid or the methane pipeline network over the next few years, actually by 2030. But all of those other measures on the bottom right, which are leadership measures by local governments, such as district energy, or the very bottom right, tiered energy codes that allow local governments to elect, to voluntarily regulate higher levels of energy efficiency and decarbonization. They all contribute towards that market transformation that will get us the political will to enable the regulations on the top right. And over on the top left, those are the things that affect all buildings that are really trying to influence behavior in buildings and investment decision making, such as carbon taxes, $55, $60 per metric ton going up to $170 by 2030. Rate design and rates, that is really important. In BC, we have a two-tiered rate for residential. It's been phased out for commercial, and it's about to be phased out for industrial. And we have, it's called the residential inclining block rate. And over a water heating load, you end up paying a higher price per kilowatt hour. And so that actually very much disincentivizes electrification and space heating with heat pumps. So rates are very powerful. And then on the bottom left are the things that are very foundational, like R&D. So the proposed policymakers that are in the roadmap are the following, and you can read them, and then I'm going to walk through each of them individually. So the first one is facilitate integrated demand-side and supply-side planning. And it goes back to that original chart, that the way we're going to decarbonize is with a combination of demand-side measures and supply-side measures. And I don't know if you've ever seen a market transformation curve, which is kind of this exponential curve that goes from 0% market share to 100% market share, and there's a very steep climb. So I've rejigged that market transformation curve to show that supply-side measures can drive down demand and carbon, and demand-side measures can drive up decarbonization simultaneously, and they're very important. And the most important reason why we need to do both, is that the energy transition will not be affordable unless we influence the demand side. So for 20 years, energy efficiency was the primary way that we were decarbonizing our society. And now energy efficiency is the primary way that we are going to make the energy transition affordable. So just literally in the last 5 years, energy efficiency has seen its renaissance. Because it used to be, oh, we can't afford that condensing furnace, or we can't afford those triple glazed windows. And now, as we decarbonize the supply, and we go from $8 per gigajoule natural gas to $30 per gigajoule blended hydrogen, renewable natural gas, or electricity, which is actually more expensive than $30 a gigajoule, we cannot afford to not pursue triple glazed windows and condensing furnaces. So I think it's great. Energy efficiency has finally seen its renaissance. Now, the key point on that integrated planning is that we are, which is the number one principle, is that we're finding the optimum policy solution. So, and we're avoiding duplication of effort. But what is the role of engineers? So government can enable performance outcomes in their codes and standards and regulation that foster competition and enable innovation. So how do we do that? First of all, we establish common performance metrics across all government institutions. Where are we all going to simultaneously together, even though the silos exist? Alan Winter mentioned, Dr. Winter mentioned, and so did Senator Galvez. Empower professionals to co-optimize design across goals. I still remember the conversation in the hallway when I was in an engineering firm. Do we design buildings to achieve compliance with the code, or do we design buildings to maximize performance and to achieve the outcome that is sought by the codes? And that is actually a debate that happens because the codes are static and inflexible. Now, there's a little known fact in Canada that we have this thing called alternative solutions. You can actually ignore the prescription for building design and go with an alternative solution that achieves the objective. The objective is to minimize energy waste and through energy efficiency. And that exists in Canada, and it's actually used fairly commonly. For example, in the stairwells in parking garages. I don't know if you've ever seen in an underground parking garage a glass stairwell. You walk from your car up to the elevator, and there's a glass enclosure around the elevator room. That's an alternative solution. And it's because the code didn't make sense. So the engineers came up with a design that achieved the same objective around fire safety and also contamination of the elevator shaft from vehicle exhaust with a different solution. And what it also does is it enables safety because, underground parking garage areas, there's a safety issue. So we have the tools today, so how come engineers aren't using them? We also need to maximize flexibility to achieve the goals, and that goes along with it. And by having the flexibility, what that does is it promotes innovation, and it fosters competition and cost reduction. And that's our responsibility, is to deliver co-optimized solutions at the least possible cost. And fortunately, in BC, with our energy code, we've now switched in many cities to an entirely 100% performance-based energy efficiency code with no prescriptive requirements. And you can get from A to B in 10 different ways. You could build a thick-walled house with no space heating system, or you could build a thin-walled house with the most efficient mechanical system, and they're both legitimate in the BC code. And what that does is it does bring out innovation. So performance-based codes, that's how we get innovation in the building sector. And I've been talking to other engineers about bringing that methodology to fire safety-related design standards and fire protection and structural protection of buildings. Develop adaptive design solutions to avoid dead ends. And we heard Senator Galvez mention the concern about going down the wrong pathway and hitting a dead end. Focus on risk identification. This is where resilience comes in, and a responsibility of engineers to not just look at the historic weather set that is in the National Building Code of Canada to define building design, but to look at the extreme conditions, because of course you can average out all of the outliers of extreme weather events. And definitely the heat dome in 2021 was an unprecedented event, and it will not show up in building codes unless we start to incorporate extreme into our design and building in that resilience for those extreme events as well. In fact, we'll hear more about that from Christy. And to communicate, this is a key, is that engineers need to play an active role in policy making, and not just sitting on code committees, but also going to Parliament Hill and the legislature down the road here to talk about what are the challenges, what are the opportunities, what are the success stories, and how can policy change to maximize achievement of those success stories. The building sector is one of the most heavily regulated sectors of the Canadian economy. How many different legislative and institutional frameworks exist for the building sector? They're in front of you. We always think that, oh, there's just the building code. Okay, there's land use planning, driven by local governments. So right now, all of the legislative frameworks, the silos, and the institutional frameworks are along the blue. They're horizontal, okay? And do they talk to each other? Sometimes if the government officials who work in the Community Charter, the Local Government Act, and the Vancouver Charter, which is the top line there, if they meet with the Office of Housing and Construction Standards, which is the building code, then there is that integration that occurs. But in fact, we do have quite a bit of fragmentation. And I think my thesis, my proposal, is there's only one profession that bridges all. How many of them are there? 2, 4, 6, 8, 9. All 9 of them. And what is that profession? It's engineers. The engineering profession works in all 9 of those sectors. And so, yes, we could leave it to government to solve the silo problem, the lack of integration, the fragmentation, but I think there is a role for government. And in fact, if you look at the Code of Ethics, engineers are required to adhere to the law. And there are multiple laws. It's not just the building code. And so we are actually empowered to tell our clients that, what about the EV charging bylaw that's in the District of Saanich, that's in their development permit area guidelines? We are obligated to talk about seismic safety because that is a public health related issue. And yet it doesn't enter into the design solutions. Right here in Victoria, this is a very seismically active zone. We have 3 types of earthquakes here, and haven't had it for a while, since the 40s. And yet many design solutions for existing buildings do not incorporate seismic safety. So that is not actually currently regulated in BC because existing buildings are not covered by the BC Building Code. But it is, if you will, an ethical obligation to raise that. And that's where the discussion about risk comes up, and to communicate risk factors directly to our clients. And then there's also separate equipment standards. So I used to work in that area, and we were the first to phase out incandescent light bulbs. That was one of my, through my career, it was one of the accomplishments through the Energy Efficiency Act. So what that does is it eliminates that technology from the supply chain, so that when the engineering design occurs at the building code level, you simply can't buy incandescent light bulbs or atmospheric furnaces as opposed to condensing furnaces, or water heaters that are 80% plus, which is now regulated in those regulations. So the proposal to government that I submit we as the Canadian Academy bring to government is to change the way these institutions are planned and flip it to the vertical approach, to plan around all 9 of those legislative frameworks in tandem, simultaneously, and to find the optimal solution for the housing sector and commercial building sector, the government building sector, and the social housing sector, to find the optimal pathway, both from a design perspective as well as a policy levers perspective. And the good news is that the National Building Code of Canada and the Canadian Code Development System, as of about a year ago, has achieved that. Under the Canadian Free Trade Agreement, the Construction Codes Reconciliation Agreement, we now have a harmonized national code development system. And literally just in the last couple of months, I've heard that it is working, that we don't have provinces that are going on their own, developing their own codes and standards. Instead, they're investing in the national code system to make it more active and adaptive to changing markets and changing conditions. And the good news is the National Building Code of Canada will incorporate climate adaptation measures in 2025, which means that it will show up in buildings in 2027 in BC. The fourth principle that I submit is important to consider is that we build resilience and decarbonization. We piggyback it onto pre-existing investment triggers. Rather than creating a new reason to invest in buildings, rather we piggyback on existing levers. So on the top left there, land use planning and pre-design of buildings, that occurs once in the lifetime of a building. So let's say once every 100 years. Then we move to the right, and you've got design, construction, and commissioning, and that's where the building code comes in. That occurs maybe once or twice in a building life cycle if there's a major reconstruction. The third one occurs every year, which is the operations budget and something called recommissioning or retro-commissioning, and that occurs every 3 to 5 years. And then the fourth one also occurs every 3 years, which is the capital asset management plan and the capital planning, which is updated every 3 to 5 years. But the big one that's really going to make a difference is number 5, and it's currently an unregulated space in Canada because there isn't a building code for existing buildings as of yet. And that is the domain of engineers, and that's where we can bring in the risk factors. And there's a big question that occurs at that point, which is, do we do a major renewal of the existing building, or do we demolish it and do reconstruction? And I think what we're learning here in BC is that the existing building stock is the affordable building stock, and new construction is a lot more expensive, and it will render those units unaffordable in the context of even the missing middle, which is people like myself, middle class, in this province with the housing affordability crisis. So major renewals is really key. So what I'm getting at here is not to create a new circle called decarbonization or resilience, but rather to piggyback onto those existing investment triggers. And then the conversation switches from what is the payback on investment to what is the incremental cost over and above my existing investment, and it makes it a lot more palatable. And then finally, digitization of construction, and I submit digitization and data-driven codes. And we have one code, it's called an energy code for existing buildings. It's called ASHRAE 100, and it is entirely based on measured data, measured performance data. And wouldn't it be amazing if in the future that the Energy Code of Canada was based entirely on data of actual performance figures that are measured in actual operating buildings, and the Energy Code's job is simply to cut off the lowest 50%, and it automatically ratchets up as buildings are higher performing. And that's essentially what this ASHRAE 100 standard does. So the call to action for engineers is that we need an expanded role. because we serve multiple building sector stakeholders. The 9 silos that I had is the horizontal slices. Although it is different disciplines or sub-disciplines of engineering that serve each one, we work aside architects and urban planners, structural engineers, electrical engineers in the civil engineering field that is so dominant in the building sector. So we have the opportunity to do that, to serve those multiple silos simultaneously. We also have the opportunity to bridge with different governments and to talk about the conflicts. And in fact, engineers and geoscientists of BC, when I was in charge of the BC Building Code, came to us and said, you know, the elevator standard in the code is different than the elevator standard in the Safety Standards Act. So that's an obligation of engineers to bring that up. And in fact, at the time, we weren't fully aware of that. The delegated institutions were probably aware of it. We know the City of Vancouver was aware of it because they have a lot of elevators. In fact, they have elevators for cars in Vancouver, you know, to bring them up to parking. And yet, you know, if it wasn't for EGBC coming to us and actually preparing a discussion paper on that, we wouldn't have taken action on it. And to align with our code of ethics, and this is where we depart from regulation as our guideline for all of the work we do, but to bring our code of ethics in and to bring that risk management lens into our practice. To hold paramount the safety, health, and welfare of the public, including protection of the environment. So we are in a unique position to catalyze meaningful action on these policy goals, while highlighting the limitations of design solutions in the context of management practices, local context, and a changing climate. For example, air tightness and backdrafting of fossil fuel appliances creating a carbon monoxide hazard. Okay, so right there I've just named 3 objectives of the code. Am I running out of time? And I'll pass it over to Christy, yeah. So you'll see in the roadmap, this is the roadmap for engineers, and I encourage you all to look at it with some very tangible actions that can be taken. And my final remarks are, these are the next steps, that the summary is to provide guidance, these proposed policy principles, and a call to action for engineers. Thank you.
Hello, everyone. How's everyone doing? Thinking about lunch? My name's Christy Love. I'm a professional engineer in BC, and I'm a principal at RDH Building Science, located here in beautiful Victoria. Let me just check how this thing works here. Cool, okay. So I've been told I have 15 minutes. I realize we're running a little bit late, so hopefully you can all hang in there. So I'm really inspired and humbled by the presentations I've heard this morning, and I really hope I can add some small piece to that conversation. And really, I want to take sort of a lot of the themes actually that we've heard today and what Andrew's presented and bring that down to the macro level. So, and share some of my day-to-day experience as a consulting engineer, and in particular working to improve existing buildings. So I've been at RDH for about 9 years, done a lot of research supporting the development of policy, both new buildings and existing buildings. And in the last few years, we've really transitioned into doing actual, what we call deep energy or deep retrofit projects for existing buildings, which is a really exciting time for me. I'm a doer. I like to see things like happen. And so there's a lot of money coming in now, and we've got actual projects. And so I'm going to share with you a couple examples of how we're sort of holding all these multiple objectives and sort of urgent calls to action in the actual work that we do every day. So, oh man, it's the font's small. I think I need my prescription changed here. So this is my thesis. So as engineers, oh, that would help, yeah. Make it a little bit bigger. Thanks so much. We really need to get comfortable considering and balancing multiple objectives. So climate mitigation, reducing our impact, as well as adapting, thinking about things like thermal comfort in buildings, safety in buildings, and of course, cost. So how do we sort of hold all those things in our minds when we're developing solutions and evaluating success in our projects? Think holistically and across disciplines. So much like the planet is a system, each building is a system with intersecting parts. You don't need to be an expert in everything, but you have to recognize that there are interdependencies, and what you make, a decision you make in terms of, say, your HVAC system could impact the electrical system or the building enclosure system. So we don't need to have all the answers, but we need to ask the questions and then bring in the experts to help answer those. Be solutions-oriented. I'm going to demonstrate that with my examples. And then I think really importantly, not wait for legislation or codes. I think we've heard already today that codes and policy, they're slow-moving machines just by their nature. We have the information we need now, and I think as engineers we can just get on with it. So 2 case studies. So again, they're both focused on retrofits. So the first one is a fairly simple one. So this is a long-term care home in Victoria. The windows are at the end of their life, and the client came to us and said, can you price a few options for us to replace the window wall? Well, sure, we can do that. We asked a few more questions about the general condition of the building. We did some openings, so pretty standard stuff so far. But the owner also shared that, the building doesn't have mechanical cooling. So these are people that are, long-term care, so some of them don't leave their habitable spaces that often. Overheating was identified as an issue in this building. So we proposed that, okay, yeah, we'll do your Class D cost estimates, but why don't we also evaluate those solutions in terms of, can we improve the thermal comfort with our glazing choices? So we sold the client on also doing an overheating analysis and looking at the sort of the life cycle cost of the options. So, better performing windows will reduce your utility costs to a degree, and sort of incorporating that into sort of a life cycle cost analysis. And we also considered both current and future climate. So many of you probably know that the codes currently require assessment of solutions relative to historic climates. So in BC Building Code, it's the 2016 files, which is an average of the 30 years leading up to 2016. And we all know that we're not living in the climate of 30 years ago anymore. So we typically use in our work now what we call future morphed weather files to be more reflective of both what we're experiencing now, as well as what these buildings are going to be performing, the environment they're going to be performing in throughout the life of the asset. So in this case, we assume the windows are going to be in place for 50 years, so we want them to be performing 50 years from now. So then in terms of what this actually looks like, we developed a few options, sort of the like-for-like replacement, just code minimum, similar to what's there now. And then we looked at a similar option, but with low solar heat gain coefficient glazing, which reduces the amount of direct solar gain and therefore improves the overheating situation. And then we looked at a very high performance option that has better thermal performance and the low solar heat gain coefficient, so non-conductive frames and triple glazing. And then we went back and said, okay, what if we just did the nominal but then added some shading, just as sort of another thing to look at? So this is just kind of an illustration of how, by defining different metrics of success, we can give a more complete picture to the client of what their options are. We're still not prescribing, like, here's what you need to do, but here's just a more complete picture. So in addition to providing the capital costs, which is what they had initially asked for, we also looked at the net present value, accounting for that 50-year life cycle and the utility savings of the choice of window. The marginal net present value is the difference in net present value relative to the baseline choice. And then we also included this sort of reduction in overheating days, so as an additional metric. So you can see that anything other than the nominal leads to a significant reduction in how we define our overheating hours. So, and this one was interesting in that the The high performance, it was sort of a very volatile market in terms of pricing when we priced this. The high performance option was actually cheaper than the baseline metal window, so it was kind of a no-brainer, but so that turned out pretty well. So this is one that I'm working on now and is consuming most of my time. It's a really exciting project. We're doing a deep retrofit pilots on 4 multifamily buildings across BC. So a mix of building types, as you can see, a couple different climate zones represented, different ownership types. So these are all rental buildings. 2 are market rental and 2 are affordable housing. The project is funded by Fortis, and the challenge that they put to us is how low can you go in terms of emissions and energy reductions without fuel switching. So these are all older multifamily buildings, kind of the affordable housing stock that Andrew referenced. They all have central natural gas-based hydronic heating systems with like in-suite radiators. They all have central natural gas-based domestic hot water heating. They all typically have end-of-life enclosure systems as well. So the goal, sort of the stated objective of this program, the intended outcome is that Fortis is developing an incentive program to roll out across the province. And so these are sort of proof of concept of what's possible. So the highest level objective is to achieve 50 to 80% energy and emission savings while maintaining the gas-based systems. We're also replacing end-of-life systems, so that was part of the selection criteria, so that we're not creating unwanted or unnecessary embodied carbon impacts by disposing of perfectly good materials and systems. And these last 2 are really important, and they were maybe not kind of sort of at the high level, the stated objective, but in conversations, Fortis agreed that it was really important that the people living in the buildings felt that this project was successful, and that in a residence, that means that you're happy and you're healthy in your home. These are people's place of refuge. As we saw with the heat dome, most of the people that died in the heat dome in BC died in their homes. So we can't not think about that. And then the building works well today and in the future. So back to that concept of looking at the future climate and making sure that those long life assets that you're specifying today are going to perform in 40 years, because they're probably still going to be there in 40 years. So looking at kind of the first item and the last 2, those could potentially conflict with one another, because a lot of these older rental buildings have deficiencies. Most of them do not have mechanical cooling. Most of them do not have filtered, balanced ventilation. So if you're to add those systems, you might be compromising your energy and emissions targets. So how do we juggle all that and come up with a solution that works for everyone? So this is one of them. It's a low-rise wood frame building in North Vancouver, affordable rental housing, typical of sort of 1970s build, single glazed aluminum windows and sliding glass doors, all the systems ready for renewal. And a couple of key elements of this building: there were known overheating issues. There was a tenant survey, and pretty much everyone said it was way too hot in the summer. And there were also electricity constraints. So we knew that any significant increase in electricity consumption would necessitate a building level electrical service upgrade, which is something that can be done, but in the case of this project, it would have kind of killed the project schedule and also cost. So what we can do, this is just an illustration. Like I said, the tenants told us that there was an overheating problem, but we can also pull information from our hourly energy model, which we create for each building, and we use that to test solutions. So this is not necessarily accurate, but it provides a way to compare solutions. So you can see here that in the warmest suite, and using the 2020's weather file, the warmest suite has something like 1,500 hours above what we call an acceptable kind of temperature. And that's like, if that all happened like consecutively, that's like 2 months of continuous, time that's above 26 or 27 degrees, which I think we'd all agree is unacceptable. And then we also pulled peak temperatures out, which again, we did see temperatures well above 40 degrees in a lot of residences during the heat dome. So this model is not necessarily that far off. And then in the 2050s, it just gets worse. So no surprise there. So these are the solutions that we are designing for this particular building. The first couple are really around demand reduction, so improving the performance of the enclosure, which reduces the energy demand. So to Andrew's point about, we saw Sweden using about half the energy of Canadians. We really do waste a lot of energy, and it's kind of a win-win. Like anything we can do to reduce energy is a plus, but also focusing on enclosure does also improve the resilience of these buildings. So, when there is that power outage in the winter, these buildings will maintain heat for longer and remain habitable for longer. So there's other benefits to doing that. And then we've got more efficient gas-based systems that are more than twice as efficient as what's there now. Some solar domestic hot water preheat, drain water heat recovery, and then we're adding in-suite heat recovery ventilators to address that ventilation deficiency. And then we're also adding mechanical cooling. And we put a lot of work into figuring out a system that could maintain that sort of central hydronic heating system while also providing in-suite cooling. And maybe I can talk more with you more about how that works for those of you who are interested at the break. So I'll just keep going in the interest of time. But we did come up with a good solution, and then we tested that solution in our model. So the top row here is the baseline energy use intensity, and then the second row is the sort of the preferred solution before we've added the cooling system. So that just allows us to compare kind of more like apples to apples, and then we add on the mechanical cooling, and we see that we are using a little bit more energy, but we're still saving over 55% overall. So that's pretty good. So we've basically added a whole new system to this building to address a major deficiency, and we're still seeing significant savings. And that's a testament to the demand reduction priorities that we have for these projects. Same idea with emissions. And just to show that this overheating analysis, we can look at individual measures. And the second to the bottom row there is before we've added cooling, the overheating hours. So with everything, all the passive measures, and that really just shows that the passive measures do make a difference. So the enclosure upgrade, ventilation that has night flushing can basically half the overheating hours, and then your cooling system has less work to do when you add that. So yeah, I'll wrap it up there and just say that there are solutions that balance these multiple objectives, provided that we as engineers, we educate ourselves and our clients. We test solutions against broader metrics. So I'll often ask my staff to just model this extra scenario because I'm curious to see, test the sensitivity of certain decisions and just dive a little bit deeper whenever you have the opportunity. And I always learn something new. I think I've touched on the other points. In terms of being solutions-oriented and proactive, I think other speakers had mentioned, none of this is easy, especially when we're using new technologies or doing something that isn't already very visible and proven in the market. So we have to be very solutions-oriented. So, one example, well, the whole cooling question was one example, and we were initially told that cooling was not in scope for these pilots, and so it took some sort of prodding, and of course, our client came around and recognized the importance, and we sort of kind of shifted our approach and found a way to make that work for everyone. Another example was the heat recovery ventilators that we're using. They're ductless systems that just go in the exterior wall, which works well for occupied buildings. And one of the municipalities was not familiar with the technology, and they said, well, no, you have to do a fully ducted system to provide ventilation to the suites. And we could have gone away and said, okay, well, that's what we have to do now. I mean, but that's a difference of probably $2 million on the project. Also, a lot more disruption to the tenants, more hazardous materials abatement. So, we went back to the municipality and proposed solutions, and then we're ultimately following this alternative solution approach to push that through. But that takes some persistence and some extra work to make those solutions happen. So with that, thanks for listening.
Thank you so much, Christy, Andrew. You know, it's interesting, when we look at reduction of greenhouse gas footprint, we use sort of what's a fairly common global model of that basically looks at 4 pillars. So there's all of the energy that's used in producing energy in Canada, all the energy that's used in transportation, all the energy that's used in industry, and all the energy that's used in buildings. And they're almost equal. You know, what's different is there are 1 million players in the business space across all levels of government. It is a nightmare. You can't just regulate an industry or a few major players. So this work on trying to find ways to find common approaches that people can agree on across different municipalities and areas is vitally important, and one of the trickiest things for any individual government agency to actually deal with, because it is so cross-jurisdictional. So just thank you so much for the effort that you and the team and everybody else has put in, and hopefully everybody will take a look at it and look at the report that's coming out. And I guess we're formally launching it in the next...
Yeah, it's been posted this morning.
Yeah, as a draft, and then we'll...
So in the fall, yeah.
In the fall. Okay, very good. Thank you so much. So we're running a few minutes late.